The Sky This Month, with your host, Dave McDonald.
Hi, welcome to The Sky This Month for the end of May and June 2019. I'm your host, Dave McDonald, and we have a great month ahead for you. Some great planet activity, and the Belmont High School Astronomy Club had the privilege of interviewing Dr. Alan Stern, who's the principal investigator of the New Horizons mission, which flew by Pluto, and then on January 1st, flew by Ultima Thule. So we have an update on that as the Belmont High School Astronomy Club students had the opportunity to interview by phone Dr. Alan Stern. So that's kind of the main feature of the show. And we're going to conclude the show with a music video that Brian wrote and produced. So we're going to start with the sky at night and talk about what's going on for the end of May and June. Well, the end of May, the two stars, if you will, they're planets of the show, are Jupiter and Saturn. So it's kind of late. We're talking 11 o'clock at night, the last week of May. And I'm going to step out of the way here so you can see Jupiter, and you can't miss it. We're looking southeast. And Jupiter will be the brightest object in the sky unless the moon's in the area, which it won't be at that time of the end of May. But Jupiter shining at an amazing negative 2.7 magnitude, sporting a 45-second of arc disk if you look through a telescope, so pretty large. That's 11 o'clock at night. But if you go on to 2 hours later, then Saturn is going to be rising. So 1 o'clock in the morning at the end of May, and then as we get in to June, it'll become earlier and earlier. So the two objects, Jupiter, you can't miss it, brightest thing in the sky. Saturn also very bright to the lower left as you look at the sky of Jupiter, and Saturn very bright, kind of a little bit yellowish in color. So a couple things to point out is, one, Jupiter will be at a position we call opposition on June 10th, and that means it's exactly opposite the sun. So when the sun sets, Jupiter rises. And being at opposition, it's also the closest and the brightest. So if you have a telescope, you want to check out Jupiter, check out its moons. That's like the ideal time. But a week on either side is fine. 2 weeks on either side. I mean, June is a great month for viewing Jupiter. And then we have to wait until July 9th for the opposition of Saturn. Saturn will be in a position of opposition exactly opposite the sun in the middle of July, July 9th. So another thing I want to have you pay some attention to is Jupiter is making its way towards this bright star Antares. Antares is reddish in color. Nowhere near as bright as Jupiter. It's a magnitude 1 star. Jupiter at magnitude minus 2.7, so we're talking 15-ish times brighter than Antares. But Antares is reddish. It's the heart of the Scorpion, and Jupiter is in what we call retrograde motion. It's actually moving from east to west against the background of the stars. And Antares being a star, Jupiter is making its way slowly. So over from week to week, you can check it out and watch Jupiter approach and get closer to the star Antares. So that's what's going on with Jupiter and Saturn, end of May. And then when we get to opposition again, which is June 10th, when the sun sets, which is going to be in the vicinity of 8:15 or so, that's when Jupiter is going to be rising. And then a couple hours later, 10:15 or so, Saturn will be rising mid-June. Then the next stars of the show, which are also planets, are Mars and Mercury. This is the month to see Mercury. There's a lot of viewing opportunities for Mercury, but you have to be intentional finding it. This is a view of June 5th, the first week of June here, and you can see the moon, which I have on June 5th because it helps you find Mars to its lower right, which is dim, a magnitude 2 or so, and then you can see how Mercury is hugging the horizon. We're about 9:15. You can see there's still a little bit of light happening on the horizon, and this is a very flat horizon. We don't have any hills or trees here, and Mercury is really, really close. This is the beginning of June, around June 5th. But the moon will help you out, and then on June 6th, the moon will be higher and will be pointing towards the stars Pollux and Castor. These are the twin stars, and you'll be able to see them pretty nicely. Castor to the right, Pollux to the left, and then on the June 6th, the moon will be in this vicinity here. Because remember, the moon moves from west towards the east from night to night. So that's going to be a great opportunity to catch the moon passing by Mercury and Mars and then Castor and Pollux. Now, June 18th, check this out. This is really unbelievable on this next slide. We have now Mercury and Mars so close together. They are like 2/10 or 1/5 of a degree, which is like 1/10 of a full moon. They're really, really close to each other, and certainly will be in the same binocular field. So if you have binoculars, this is a great time to check out Mercury and Mars on the 18th of June. But again, either side of the 18th, they're still going to be really, really close. And then Mercury reaches a point we call greatest eastern elongation on the 23rd of June, which means that Mercury will be highest, that it will be above the horizon after sunset, but it's always in the lit sky. It's never in a dark sky. And then don't forget the summer solstice, which will be June 21st, 11:54 a.m., the first moment of summer, and we don't want to miss the summer solstice, okay? And hopefully it'll be a nice, comfortably warm, dry, but enough water summer for us. So those are some neat things. So I want to move towards this video segment that I want to share with you, where my astronomy club from Belmont High School, we had Dylan and Adam and Hunter and Bryce, the four of them, and then Cody was not able to make it to the studio, but he did bring in a question. And so tremendous opportunity that Dr. Alan Stern would talk with us over the phone line. So the phone line is not exactly the best connection ever in the world, but it's plenty easy to be able to understand. And then we tried to put some video clips or some pictures that were related to what Alan was talking about, and that was done post-interview. And so one image I want to just share with you before that is the Pluto salute. When I had the opportunity to be down at Johns Hopkins University, and we got to meet and talk with Alan Stern in person. So obviously I'm on the left, that's my daughter Sally on the right. Alan is in the middle, and behind us is a 1/4 scale model of the New Horizons mission. But a topic very near and dear to Alan's heart is the planethood of Pluto, and you can see the significance of the Pluto salute there with 9 fingers showing, and I'm sure you can figure out what that means. Okay, so enjoy this. It's about 19 plus minutes, and then we'll come back and close out the show. So enjoy this interview as Belmont High School Astronomy Club interviews Dr. Alan Stern via the phone line. Hello, welcome to our show, Dr. Alan Stern.
Hi, it's great to be here.
Well, we're really happy to have you with us, and I have my students from the Belmont High School, New Hampshire Astronomy Club, and Hunter is going to start with the first question.
My name is Hunter. I was just wondering, for everybody who doesn't know, what are the goals of the New Horizon mission when you set out?
Yeah, well, New Horizons is a space mission of NASA's with the primary goals of making the first exploration of Pluto and the third zone of our solar system, which is called the Kuiper belt.
Okay. Hello, my name is Dylan. I have the second question here. It's kind of a three-part question. The first part is, when was the New Horizon mission launched? When did it fly by Pluto? And when did it fly by Ultima Thule?
New Horizons was launched in January of 2006. In fact, on the 19th of January, 2006. And then we spent the next 9.5 years flying to the frontier of the solar system, 3 billion miles from Earth, and arrived for closest approach to Pluto on the 14th of July, 2015. And then we retargeted the spacecraft to intercept Ultima Thule, and that took place on January 1st of this year, 2019.
Hi, Dr. Stern. This is Bryce. When will this mission end? And what are any other destinations that it may pass?
Well, New Horizons is currently conducting other exploration of the Kuiper belt using its telescopes and cameras this year and next. And then we're going to propose to NASA to try to find another flyby target sometime in the 2020s and to go there. We have enough power and fuel to run the spacecraft for almost another 20 years. So there's a long lifespan and a long expected return to come from the mission.
Certainly a lot of potential. Hello, Dr. Stern. My name is Adam, and my question is, how fast is the New Horizons spacecraft traveling through space?
The spacecraft is traveling very fast, at a speed of just over 14 kilometers per second, so just a little under 10 miles per second. At that speed, the spacecraft could cross from California to New Hampshire in about 4 minutes.
Thank you. Another question is this the farthest that we've ever traveled in space, or is there any other ships that have gone farther?
In fact, 4 spacecraft have gone farther. 2 of them, called Pioneer 10 and 11, have now run out of power and are just derelicts flying through space. Another 2, called Voyagers 1 and 2, are still operating and still returning scientific data from a distance about 3 times as far away as New Horizons. So very, very, very far. But nonetheless, none of those spacecraft flew past anything after further out than Voyager 2, which explored the planet Neptune in 1989. So New Horizons broke that record by exploring Pluto further out, and then by exploring Ultima Thule, which is still further out beyond Pluto by about 1 billion miles.
Interesting. Next question is, how did you end up finding Ultima Thule, and what types of technology were used in order to locate it?
We searched for targets to fly by after Pluto using the largest telescopes on the Earth, but were unsuccessful in finding anything that we could get to with our available fuel. We found lots of targets, but none of them were within our reach. So in 2014, we decided to use the Hubble Space Telescope and make one last search. And the Hubble found 3 targets for us that we could reach. And we chose Ultima Thule from among those 3.
Why did you name it the Ultima Thule?
Early in 2018, we conducted a public naming contest in which the public could go to a website and suggest names, and then people could vote up the ones that they liked. And Ultima Thule, which is a Latin phrase for beyond the farthest frontiers, beyond the known world, went to near the top of the list. And then we sat down with NASA and took the getters and chose among those for the name of the target. And we liked Ultima Thule best. So since it was very much what we are actually doing, going beyond the known world and the farthest frontiers, that became our choice.
Well, I believe it's a very fitting name. Next question is, what is special about Kuiper belt objects in general and Ultima Thule in particular?
Well, what's special about Kuiper belt objects in general is that they come from, or they reside very far from the sun, where the sunlight is so faint, about 2,000 times fainter than it is broad daylight on the Earth, that the sun can't warm objects out there very much. Their temperatures are almost at absolute zero.
Oh,
and
wow.
that means that the objects are in a deep freeze that prevents them from evolving, particularly small ones that don't have strong geologic engine.
Wow, that's...
So the Kuiper belt really is like an archaeological dig into the ancient history of the solar system 4 billion years ago. With respect to Ultima Thule, there are two things that make it special. Probably the thing that makes it most special now is that it's the only Kuiper belt object that's been explored by spacecraft, thanks to New Horizons. And so we know a lot about it. But what originally made it special is that it comes from a very particular part of the Kuiper belt, a group of objects called the cold classical Kuiper belt objects, which is a mouthful, and it's not about their temperature. It's actually about their orbit types. But we know from this particular orbit type that Ultima Thule belongs to that it was formed where it orbits now. Most objects in the Kuiper belt were formed closer to the sun and then either ejected or otherwise transported out there in the early days of the solar system. But Ultima Thule and the other cold classical Kuiper belt objects were actually born way out there over 4 billion miles from the sun. And so they represent a bedrock sample of the material out of which the outer solar system formed.
That's very amazing. So the next question is, how did the two objects that make up Ultima Thule come together?
The answer to that question is not entirely certain. And there's a lot of work ahead to really understand it, but we have some pretty good clues. From the images that we took, we can see that the two lobes of Ultima Thule are largely intact. Both their shapes and their structures look like and are giving us clues to that formation by showing us that they merge together gently at something like the speed that you would walk into a wall.
That's very interesting.
This means that these two objects were formed very close to each other. That is another clue, and if you look closely at the shape, you'll notice that what we call the principal axes of the two objects, meaning their long axes, are co-aligned. They're pointed the same way, which tells us that for a period of time, the two objects were orbiting very close to one another before they actually merged, and that their mutual gravity acting on one another caused those boats to align that special way so that those principal axes are co-aligned. This is not a random chance event. It's something that happened as a result of their orbiting close to one another before they merged. So we believe the whole story is that they formed independently but very close in orbit around one another. And then that orbit shrank and shrank and shrank until they ultimately merged very gently. And in the period just before the merger, they were close enough to undergo this alignment of their principal axes, which we now see. So we have a lot of clues. It's kind of like a crime scene where we don't actually we weren't actually there when the crime took place, but there are clues that are helping us piece this all together.
That's incredible. That leads into my next question about Ultima. Some images that have been produced by the New Horizons mission is that it looks more flat, almost resembling like a pancake. Have you guys done any research into why it's that kind of shape instead of more like a spherical shape?
We have, and I'll tell you about it. We have a number of ideas, but it's very early in terms of sheet modeling. So I can't tell you that we have the answer. What I can tell you is that there's some possibilities for why the two are flattened. One possibility is they were really formed that way due to the spin of the material out of which they formed, the cloud of material out of which they formed. It's also possible that if the two objects were formed early enough in the history of the solar system that there was still gas around from the what we call the primordial solar nebula, that gas could have played a role in shaping their shapes, and they do look like they are reminiscent of aerodynamic shapes. So that might be the case instead. There's some other ideas around too, but until we do more work with the computer, I don't think we can say which one's most likely.
What are the bright streaks on the Ultima Thule?
No one knows. There are bright streaks and bright oval patches, and also some bright-ish diffuse patches on the surface. And there are many examples of each, but we don't know what the cause of that is. Most of those bright areas have the same composition and color as everywhere else. So it may only be a very thin surface veneer.
Very interesting. Next question is, how long is the orbital period of Ultima Thule, and how is this calculated?
The orbital period of Ultima Thule is easily calculated from Kepler's laws that have been around now almost 400 years. Simply by knowing the orbit of Ultima Thule, its average distance from the sun, and the mass of our sun, you can calculate literally on a hand calculator, it's that simple, that the orbital period is a little bit longer than 400 years.
That's cool. So Dave McDonald back, and Cody, who's our vice president of our astronomy club, is not able to be here, so I have a couple of questions from him. His first question is, how did your expectation of what Ultima Thule would be like compared to what the reality actually turned out to be so far?
You know, we knew so little about Ultima Thule before we got there. We didn't have a very strong expectation. Unlike Pluto, for example, which we had studied for decades from the Earth, we being human beings, we only knew about Ultima Thule for a matter of less than 4 years. And only the Hubble Space Telescope was able to see it. And even the Hubble could only see it as a faint point of light. So we couldn't see any details on its surface. We didn't know its surface composition. We had some hints about its shape and reflectivity. And that was it. And from that, you really can't form a strong mental picture of what Ultima Thule would be like. You could guess, but given that we were going to be there very soon, most of us, I think, didn't bother to guess and just waited to see. The biggest surprise, or surprises, were the fact that it is this very unusual shape we call a compact binary, two objects that formed separately but then came to merge. And as you asked earlier, that the object's three-dimensional shapes are so flattened, which really hadn't been seen anywhere in space exploration before.
That's neat, and obviously a very, very monumental achievement. We all have enjoyed the music video that Brian May put together about New Horizons. And how did you get connected with Brian May, and what was it like working with him?
Brian reached out around the time of the Pluto flyby. As you may know, in addition to being a god of rock and roll, he is also a PhD scientist. In fact, when Queen got started, he was already in graduate school. He put that down until the 1990s, when he found the time to finish his PhD. But he contacted myself and asked if he could come to the Pluto flyby, and of course I said yes. And over the next few years, we formed a friendship. And I saw him in England several times, and he saw me over here. And as we were getting ready for the flyby of Ultima Thule, I challenged him to write a song in honor of this exploration. And he originally said no, because nothing rhymes with Ultima Thule.
New horizons that we've never seen before. Now that sounds very similar, and I thought, I don't know if that's really going to express what I'm going to say. But I started to kind of move around that, and it became the song that I wanted to write with Don.
Good. But later he got a good idea, and he did write a song, and it was fun working with him. I found he's a perfectionist. We went through dozens of iterations on the lyrics, and then the music, and then the recording, over a period of several months from July to November. And it was a lot of fun working with him and seeing how his creative musical line works.
That's incredible. So do you have any upcoming plans for Ultima Thule?
Our plans are to analyze the data, which is still coming back from the spacecraft. But we're not going back to Ultima Thule, so we have no plans for further exploration of it, only for better understanding the data that's already on the ground and getting the rest of the data back.
Okay. All right. This last question before we conclude is, what is the most satisfying part of your work, and what is the most frustrating?
Well, I think the most satisfying part of the work is how people respond to it. The people on the project who've worked so hard for 15 years, being rewarded by not just the technical success, but the scientific breakthroughs that we've made. And the people in the public who find inspiration in this and pride in their country for setting records and exploring deep space. I think the most frustrating aspect were the years that we spent trying to convince the Washington establishment that this is an important thing to do, because it took 12 years of that before we were given a chance to design and build a spacecraft and then fly it across the solar system. But it all turned out in the end, so on balance, it's been just spectacular. And thank you for your interest in the project.
Well, Dave, back here, and so my students really appreciate the time that you've taken to speak with them about this New Horizon project, which goes on, and hopefully we'll have at least one, if not more, targets to visit in the future. So congratulations on such a successful mission so far, and we wish the best for New Horizons as it continues into the future.
Well, thank you for all that, and all the best to all of you, too. And I hope you have a good weekend.
Thank you, Alan. You too. Thank you very much. Well, I hope you enjoyed that video segment with the Astronomy Club talking with Dr. Alan Stern. It was a great privilege for him to spend some time with us about the New Horizons mission. And you noticed on there about Brian May. Well, as you know, he's an astrophysicist, Dr. Brian May, and clearly a musician, lead guitarist for Queen, one of the founding members of Queen. And he wrote, as was mentioned, a song and a music video specifically for the New Horizons mission. And I thought in just a moment we'll close with that. July is coming up, and that is the 50th anniversary of the Apollo 11 landing on the moon. So for our July program, we'll be featuring the moon and some of the matters and people related to that. So check out YouTube, and you can search for Brian May, New Horizons, and this video will pop up. Brian May, New Horizons. Enjoy this video as we close out the show.
T-minus 15 seconds.
Ready. Roger.
15 seconds. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff of NASA's New Horizons spacecraft.
The revelations of New Horizons may help us to understand better how our solar system was formed.